Homework 16, the central limit theorem for proportions, video 5. Probabilities involving proportions, example 2. Let's take a look at one more example. 48% of teenagers own a smartphone. I don't know how accurate that is, but let's go with it. A sample of 100 teenagers is selected. Find the probability 50 to 55% of them own a smartphone. Let's start by identifying what we're given and what we're being asked to find. When we're told 48% of teenagers own a smartphone, we're being told 48% of the population have a characteristic. That's the definition of P, not P hat, P, as a decimal 0.48. A sample of 100 teenagers is selected. That's lowercase n. This is what we're given. We're being asked to find the probability that out of the sample, between 50 and 55% of them own a smartphone. So we're looking for a probability about the percent of the sample, which is p hat. Now we're looking for the probability that this p hat is between two values. So we'll say 0.50 is less than or equal to p hat, which is less than or equal to 0.55. So that's what we want to know, and that's what we were given. So let's map out our plan of attack. If we were to sketch the bell curve for the p hats, assuming that they're normally distributed, and we'll check that in a moment, then the middle would be the average of all the p hats, which by definition is p. So 0.48 would be here. Both 0.50 and 0.55 are to the right of that, somewhere. And so the probability that p hat is between those two values will equal the area shaded between those two values on that bell curve. So we need to figure out what the z version of this problem is, and then use the z-chart. But first, and honestly you can get away with this, we won't be put in a situation where it's not normally distributed because it would require techniques beyond the scope of this course. But we should verify that both np and n times 1 minus p are both greater than or equal to 10. It's not that hard. N is 100, p is 0.48, that product is exactly 48, that is greater than or equal to 10. For n times 1 minus p, n is still 100, 1 minus p represents the other percent, so if 48% own a smartphone, then 52% do not. So 0.52, 100 times 0.52 is 52, that is also greater than or equal to 10. So everything is acting normal and we can proceed. If for some reason in the homework, one of these was not at least 10, the problem would end right then and there. It would not be appropriate to use a normal distribution. All right, so now we're going to have to convert this to a z problem, and recall that the formula for z needed mu sub p hat and sigma sub p hat. So the next thing we should do is calculate those. The formula for mu sub p hat is mu sub p hat equals p, which is just 0.48. And the formula for sigma sub p hat is the square root of a fraction with n on the bottom, p times 1 minus p on the top. So under the square root in the denominator we have 100. And in the numerator we have p, which was 0.48, times 1 minus p, which is 0.52. And so now we just have to calculate that. Now we just have to calculate that. 0.48 times 0.52 divided by 100, and hit the square root button. So to 4 decimal places, this is approximately 0.0499. Actually, what it is 0.04995. So we're rounding to 4 decimal places. We look at this 5, it's going to cause the 9 to round up to 10, which will cause the 9 to round up to 10, which will cause the 4 to round up to 5. But don't overthink it. This 5 basically says, look at this number and go up to the next one. So the next number after 499 is 500. So 0500 is what our sigma sub p hat rounds to 4 decimal places. Okay? Now we need to convert each of these p hat values, or values that we're comparing p hat to z values. So let's start with p hat equals 0.50. P hat equals 0.50 will convert to z equals, I'm not going to write the formula, but I will set it up. The formula was p hat, which is 0.50, minus mu sub p hat. Mu sub p hat was 0.48 over sigma sub p hat, which was 0.0500. And now we got to figure out what that equals. It looks like it's going to be 0.4. And actually it's not approximate. It's exactly that. But I better not be arrogant. I better just get out the calculator and verify that. I used a little bit of number trickery and took advantage of the fact that the denominator was actually pretty simple. But it's 0.4. But we also have to convert the other p hat value that we're comparing p hat to, and that would be 0.55. So p hat equals 0.55 converts to z equals the p hat that we're converting, which is 0.55, minus mu sub p hat, which is still 0.48, over sigma sub p hat, which is still 0.0500. Let's see if I can go 2 for 2. This should be 1.4. But, not to be arrogant, I would rather be precise. 1.4. So what does that tell us? That tells us that the answer to the question that we're looking for is equal to the probability that z is between this guy's z value, which was 0.4, and this guy's z value, which was 1.4. Let's sketch a picture for this real quick. Remember, on the standard normal distribution where this horizontal axis is z, the center is 0. And we're looking between 0.4 and 1.4. So let's just locate some places to the right and put 0.4 and 1.4. Shade them in. The only thing I know about this answer just from this picture is that it's less than 50%, because half of the area is to the right of 0, and this isn't half, it's not quite half of it. So do you remember how to use the z-chart to find the area between two z values? Remembering that the z-chart tells you left areas. The answer is look up both left areas and subtract them. If we look up the left area for 1.4, it will tell us everything to the left of 1.4, but we don't want this piece, which is the area to the left of 0.4. So if we look up both of them and subtract their areas, we'll get our answer. For z equals 1.4, remember the z's in your z-chart have 2 decimal places. So if you want to put an extra 0 after each 4, that's okay. For 1.40, we would go to the 1.4 row and the 0 column. 1.4 row, 0 column, the area, 0.9192. But then we have to subtract the area to the left of this that we don't want. So we would go to the z-chart, go to the 0.4 row, and the 0 column. 0.4 row, 0 column. The left area is 0.6554. And then we just subtract. I'll just do it with the calculator because I don't feel like doing it in my head. 0.2638. Or since we're answering a probability, we can answer it as a percent. 26.38%. So what does this mean? This means if 48% of all teenagers own a smartphone, and we take 100 of those teenagers, not just the ones with the smartphone, but just 100 teenagers, and then there's only about a 26.38% chance that between 50 and 55% of them own a phone. I know it's a lot of numbers to throw out there, but it is what it is. This actually wraps up the video series for this homework, this section. So let me just summarize real quick that the distribution of p-hats is normal, approximately, if these two conditions hold. These two products are at least 10. The mean and standard deviation of all the p-hats are these formulas. And if you're going to do a probability problem involving p-hats, then you convert it to a probability problem involving z's. And the actual conversion formula is not on the board at this time. So I'll just clear my space and remind you one last time that the formula to convert p-hat to z is z equals a fraction. The numerator is p-hat minus mu sub p-hat. And honestly, we could just replace this with p because that's what it equals. And the denominator is sigma sub p-hat. So that, coupled with knowing how to use the z-chart, is your way out of this homework assignment. By the way, this homework assignment has a grand total of 3 questions. The first one is calculate mu sub p-hat and sigma sub p-hat. Piece of cake. But questions 2 and 3, in addition to doing that, also ask you to do a series of probability questions. I will tell you right now that in this homework, both questions 2 and 3 have 6 parts each. So I think it's enough to practice. All right, let me know if you have any questions.